Good morning. Sorry I've been away for a while. I was ill last week, and this week I've just been busy catching up with uni stuff. I'm not doing the camera today, but I have added a camera to the project at the moment, just to kind of demonstrate. Well, I'll do a quick video on something rather than do the camera as a little breather, I guess. But mainly because the camera is going to take a little bit of time because there's a lot to write. And a lot of maths, so there's going to be a lot of explaining, so I've kind of put it off a little bit, but I will do it soon enough. So at the moment we have the weird shape with all the different colours. I've taken away the multiplication of the colour as well, so it's not glowing or anything. I need to change the movement speed actually. Change it down to 1. And yeah, so we won't go over the camera today, but we will. What we will do is do some transparency stuff. Oh, I've got that open. So transparency in OpenGL is kind of interesting because you need to. You got some weird things going on. Where is my clear function? Oh, it's there. Usually that's right at the top. I don't know why I put it down there. Oh, I don't know. So we're going to enable some things and talk about some things. Yay. So first of all, we're going to change this into a cube. So I'm going to need paint, just to kind of work it out quick. And then once we've changed it into a cube, I'll show you how to do some alpha blending so that we can change the color, so we can give it a transparent look, so like windows and stuff like that, because that's really, you see windows all the time in games. You need to know how to do that, and talk about the pros and cons of using some of the alpha stuff, because for example the depth test doesn't work with alpha enabled. I'll show you what I mean. So first of all, let's change this into a cube. So we've got minus. So this is the leftmost side, and we want to. So that's the rightmost side, and then this one will be leftmost side again. So it should be minus like that, and then the next one will be 0.5. So that's the first square. The second square, we're just going to put it back by 0.5. I should probably change the rotation so that when we spawn in the window, we're not facing the wrong way. I can't remember which one of these it is. The camera class has a big constructor, which is annoying. So we've got start yaw, which is after startup. So we change this to. I wonder if 1 is maximum. I'll tell you what, we're working on the cube right now, so we won't bother doing that. So we've got. Let's kind of explain what we're going to do. We've got 0.5 there on the X. So this is bottom left corner. This one's going to be the bottom right corner. And top left corner, top right corner. And then for these ones, it's just the same again, but so we're just going to quickly draw this box with amazing graphics. And then we're going to do these colors now. So this one's 0. The next one's 1. No, that's not 0. This one's 0. And then 1, 2, 3. So the next points are over this on the back. And then we'll just quickly connect these up actually, drawing a cube. So with our vertices so far, every single time we've been drawing them counterclockwise. I don't know if you can tell, 0, 2, 1 is 0, That's not counterclockwise, is it? 0 minus 1 0 3 2 0 3 2. Oh, and then 2 2 3 1. God, that's weird. These need to be redone, these indices, because that is wrong. We need to draw this counterclockwise, and I'll explain that a bit later. So we've got 0 1 2, and then the next one will be 0 1 2 3 4, and then 5 6 6 7. Is that making sense? So 0 1 2 3, you get it. It's 4 5 6 7, and then basically I'm going to change the color. We're going to draw these all counterclockwise. I'm looking at this like it's alien, because when I draw shapes now, I always think of it in the counterclockwise order. So this looks wrong because of the whole, because it zigzags like this. The way I've been calculating shapes so that they draw, well, so that you can calculate the vertices and indices, they always draw it so it's like, well, they always get drawn in an order so that the triangles are always correct, like that, and it just makes it easier. So you might want to think about doing it that way if you create your own shapes. So what we're going to do now is we're going to go through and we're going to just make every single face. There's going to be quite a few faces because we could always just do we could always ignore this one and the bottom one, couldn't we? And just do the cube as a flat shape. Oh, we'll just do what was easy enough. So I'm going to delete these because these are wrong. First triangle then is 0 1 3, and then because that'll create the first triangle. But now I'm looking at it like alien again, and then we just need to do it another one that's counterclockwise. So maybe we do 0 1 3 0 3 2, or should we do 0 1 3 3 2 0? I'm trying to think of what the easiest way of looking at it will be, because we need to do this for every single face. So trying to think of the easiest way to memorize a pattern to do for every single face makes it much easier. So we'll do 0 1 3 and then 3 2 0, because that's pretty easy. Then for every single one for the next face on this side, it'll be 1 5 1 5 7 7 3 1. So you're creating the triangle each time. Okay, so first one then, 0 1 3 3 2 0. 3 0, and then we'll do the next face, which will be 3 1 5 5 7 3 3 1 5 5 7 3. Next one is, so we've done this one, we've done this one. Next one is 7. Which we started here at 0, so it'd be 5 4 7. No, 5 4 6 6 7 5. No, it's not, is it? 0 1 3 3 2 0 1 5 7 7 3 1 5 4 6 6 7 5. Yeah, 5 4 6 6 7 5. So we've done the back face. Then we're doing this one, which will be 4 0 2 2 6 4 4 0 2 2 6 4. And then we're going to do, so we've done all the other sides, well, all these sides now. So now we'll do the top face, which will be 2 3 7 7 6 2 2 3 7 7 3 2 7 3 2. It's weird because I always keep thinking it's not anti-clockwise when it is. And then we'll do the last face, which is the bottom one. So we need to imagine that we're at the bottom, and every single time I'd get this wrong. So I'm just going to quickly make the shape of what the bottom is. So it's 4 there, 5 0, 1. So it's just 4, 5, 1, 1, 0, 4, 5, 1, 1, 0, 4. So that's all the vertices and indices. What's nice about this is we can see how many there are. So there's 24 there and 36 there. So we just need to put that into the object creator. I've already forgotten how many there were. 24, 36. Now you can see how good this is, because for every single one of these faces, like this kind of shows off the index-based drawing. Because this is just two lists, we've got much less data stored in the GPU for drawing. And basically, for every single one of these vertices are referenced multiple times. Look how many times 3 is referenced in this. 1, 2, 3, 4, 5, 6. So that's 6 times less data than we need, than we could have. Sorry. So we're just going to quickly check that that's actually made, and then we need to go on to actually blend in the colours. So at the moment we've just got a box. Oh, that looks wrong. What was wrong there? We've drawn a face wrong. Can you see that we can see inside the shape? That's the top face, isn't it? What did I do wrong? 4, 5, 1, 1, 0, 4. Maybe it's the 2, 3, 7, 7, 6, 2. 2, 3, 7, 7, 6. That's why it's important to draw it out so you can actually reference where you've done wrong. So now we've actually got a box. Hang on a minute. Oh yeah, that's right. Yeah. Which is nice. So now we've got the box. We're going to go into the shader, and here we've got frag color equals vertex color plus 1. Well, vertex color, which is the red, green, and blue, and then 1 is the alpha. So we're going to change this to 0.5. So we've got 50% alpha on the box, and this does absolutely nothing at the moment because we haven't got any alpha blending enabled. As you can see, we can't see through the box. To make that even clearer, I'm just going to quickly go down here, and we're going to go. Let's get rid of this space. For size t I equals 0, I is less than 4, I plus plus. And we're going to have these two in here. And basically, what we're doing, don't need those anymore. Basically, we're just going to go model equals glm translate model glm vec3, and we want let's just put I in there for the first one, which needs to be a GL float. GL float I think, yeah, just I. Why isn't that working? That's worked before. It's like I've forgotten how to convert things to flows. Oh, screw it. I'll tell you what. We want just 0.5f times I. And then 0,0f. And basically, this loops through so that we're adding that on the x-axis. We actually want that on the y-axis, the z-axis, sorry. So that we can we can see the depth as it goes on. So I'm going to quickly have a look. There we go. That looks really funny. Is the space getting bigger? Very strange. So we just got 4 cubes. Right, now on to the blending part. So for the blending, at the moment we have nothing. We've just got depth test here. So we're just going to disable that, and I've got some notes down there. This is what we need, and I'm just going to walk you through what they are. So GL enable GL blend. GL blend is what we need to actually blend the alpha channel, and here we tell the blend channel what well, the blend function, the rules basically. So we've got GL1 minus source alpha. So this basically means that once it gets to 1, that's the cap of the alpha. 1 is maximum, 0 is minimum, and then here, this is why we've been drawing the faces in a anti-clockwise motion, these two functions here. So to show those, I will actually get rid of depth test because we don't need it anymore. I will show you what they do. So at the moment we've got cull face, so we're enabling the cull face function in OpenGL, and we're culling any clockwise faces that get drawn. So at the moment, all of our faces are drawn anti-clockwise, and once we see them from behind, they are drawn clockwise, if that makes sense. If you imagine this flipped like 180 degrees, then it will be 0 would be here, 1 would be there, and 3 would be there. So you'd go 0, 1, 3, and that is instantly going around in a clockwise motion, which means that it's culled. It doesn't get drawn. And this is useful to just get rid of any faces we don't want to draw, so we save as much space, so we don't pass as much data onto the fragment shader, and save a lot of memory basically. So quickly, I'll show you what they do, because we've calculated the cube, so it should all render correctly, which it does, apart from the depth test thing. You can see what's happening. So this isn't any sort of blending. This is the objects on the back being drawn on top of the objects on the front. And I can't remember how I got around this on my other project, so you're just going to have to bear with me. This is specifically for the alpha blend, so you can ignore this for now. But this is what happens when you don't enable depth testing, basically, and you draw objects in the wrong order. So what we're going to do now is change it so it's not clockwise faces that get culled, it's the counterclockwise faces, the ones that we have decided the order that we've decided to draw in. So now these should be, yeah, I don't know if you can see very well, but we're seeing inside the cube now rather than on the outside. I guess it is kind of difficult to tell, especially since I've got depth tested. Oh, I'll tell you what, if I go inside, you can inside the cube, you can tell that we're seeing the inside of the cube rather than out, because if I re-enable this one, then oh no, done that wrong. If I re-enable this one quickly, so we're actually culling all the front faces that are going in the clockwise motion, and I go inside one of these, we won't be able to see out. Well, we can see the one next to us, but we can't actually see out of the one that we were just in. But before we could actually get inside, now we can't. Well, we could get inside and actually see it. So that's the cull faces in a nutshell. Now we're going to enable the blend features, and because we've changed the alpha channel, this should basically mean that we can see through. Well, we got like 50% transparency for every single cube, and we don't. Oh yeah, we do. We kind of do and we kind of don't. That's weird, that is. It's like the depth test is still partially enabled. Let's try getting rid of it on this one, this bit here. Oops, difficult to put in that. Come on, the most annoying thing about spawning in the wrong direction. It's like nothing's being drawn anymore. This is a problem with my improvised videos. I come into all kinds of problems. It's a shame because I wanted it to be slightly educational. What to do? No, I'm just rerunning it and it's not working. Right, I'm just going to re-enable the depth test to see what happens. It is enabled. That's why we couldn't see through it. I'm an idiot. There we go. Now they're all transparent. Oh God, I've not lost myself again. Yay! Now we've got the transparency. This probably would be easier if they were all one color, wouldn't it? But you can see why depth testing is actually, that's so weird. The depth test was working in one direction but not the other. I'll tell you what, let's quickly go into here, and we want one more object at the end, and this one is going to have, I'll tell you what, I got an idea. So we want a uniform, let's call it, this is going to be vec4 color, and basically we want frag color to equal color, and we're just going to quickly go in here. Why isn't GLM translate working? Oh, we don't have I anymore, do we? So what's this going to be? This is 4 times 0.5, so that's 2. Let's make it 3.0 just to be certain that it's definitely moved. The other thing we want to do is set the colors. So for all of these, we want, so uniform, we didn't have a UN. Uniform color, and then where have we got our, we're getting them here, but we can get here, that's fine. Shader 1 dot get uniform location, and we want color. And lastly, we want to pass this vec4 into our uniform color equals, no, what do we want? GLL uniform 4FV, no, just 4F. We want the uniform color 1 GL false, or is it true? Because it's going to be, nah, it'll be fine false. GLM, no, we just want to pass it in now. I feel like we need to be getting the shader for some reason, but no, we don't. GLM, no, it's not going to be vec3, it's going to be literally the colors. So let's make the boxes all some sort of grey, with again 50% transparency, literally all 0.5 there. So many, what's it think? Screw it, here's an easy way of doing it. So we want GLM vector color equals GLM vec4 0.5F. So we're going to initialize the color at 0.5 for the entire vector. Oh yeah. Value pointer. Still doesn't like me because I'm trying to pass in a matrix rather than a. Oh, I'm such an idiot. Right, start again, Lewis. GL uniform. At 4F, we want uniform color, and then color dot x, color dot y, color dot z, and color dot w. God damn, I can't even spell. Okay, so there we go. Every single one of these cubes is going to be grey, and then lastly we'll have one that is just red. So we'll have red, nothing else, and one on the alpha. And this is going to be a nice flat. What's the error? Too few arguments for cull. Oh, because we only want. No, it's not. Is it? Uniform. 4F. Location, then 4 floats. Color, 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 color. Why does it think that's wrong? What? Okay, whatever. So yeah, there we go. We've got a nice blend now. So everything's grey up to the point where the red box is, and we can't see through the red box because it's 100% alpha. And the other thing is, we need to make sure that we can see. So if we change this to -3, we need to make sure we can see from the other side, because you remember it looked really weird, like we weren't culling correctly, but we actually are. Even though these objects are drawn in an order so that they might appear to overlap, and we haven't got depth test enabled, OpenGL seems to be smart enough to figure that out for us. So unless you're having problems with things overlapping, you don't need to control the alpha blend in your loop. Some people tend to swap or well, specifically do it in a specific order. So for all the things you want to be on top of, say transparent materials and stuff, you want to be on top of an object, then you would basically in here you would say GLFW what is it? What have we got in there? These things basically, GL enable and stuff, we would want to enable them and disable them in the while loop. That was longer than I expected. 25 minutes, it's not too bad, but it's quite useful stuff. And I hope you enjoyed. I will do the camera at some point. I did quickly go over it in my last video and remember that much, but the maths in it are a bit annoying. Specifically, these bits are easy, and the inputs are really easy. But then when it comes to this part here, because I'm not very good at the maths, like working out what this is actually doing, I'm not very good at explaining it. I mean, I get why you need to convert to radians and how this is creating a well, basically the front position, the Y and the Z position for the front position, and then you normalize the vectors, and then in the update function you calculate the matrix for the view, which is then passed into the shader, and that's the part that gets really confusing for me. Here, when we're going saying GLM look at position plus front position up position, it looks pretty simple. It's just a bit how do I put it? Meh is what I would call it. I also want to quickly see what happens when you go to like let's be silly. I'm just going to quickly see that what this does. Oops. Oh, well, be fine. Oh well, I'm not going to be able to see what. Oh, weird. It just flips the camera. So I'm actually right. So if I keep scrolling up, I just suddenly flip and start scrolling down, even though I'm not actually scrolling. Oh, that's horrible. Yeah. I was just wondering what happened. I was reading a book in which this method is crap, and I agree with it, because there's a better way of doing it, and maybe I should work that out before I make this video. Using quaternions, something like that. Yeah. Anyway, hope you enjoyed. Cheerio.